Hey guys, so sorry for the extended break last week for weather issues. I know I've had a bunch of questions about why we didn't have at least online assignments during the closure. And the college made the decision, since so many people were out of power in the district, that there wasn't really fair to put assignments up, even if only some of the students could get to them. So sorry about that. We kind of basically lost a week there, but let's get back into it now. Because of that weather issue, also some of the parts that we were waiting on for trainers were delayed. So this week we're still kind of shuffling to catch up from the weather break. So what the lesson today is going to be is hooking up your DC motor. As you remember, you have the relays and you have a DC motor, but we haven't connected those yet. So I had you do some research to try to figure out how you thought would be best to connect and reverse a DC motor. And now I'm going to run through kind of some of the different options that hopefully you found on your own. And then we'll decide which one we're going to use. So this is a review of how do we connect DC motors, how do we reverse them, how do we avoid trying to run it in both directions at the same time, that kind of thing. So let's go ahead and get started. So hopefully you'll remember from Mech 131, we first dealt with DC motors, and then we did a lot with DC motors in Mech 132. In Mech 133, we dealt with controlling and reversing motors. And the type of DC motor that we're working with is very simple compared to some of the ones we dealt with in 132. This type of DC motor is a brushed DC motor. So if we say that's our DC motor, and we're going to label one side of it the positive and one side of the negative. So in this case, we're going to just assume that if we put a positive voltage source on this terminal and a negative on this terminal, that we would get clockwise rotation, just so we can use a convention as we're talking through this lesson. So if we want to reverse that motor, we need to switch the polarity so that positive is connected down here and negative above. So there's a couple different ways we can do that. You can do that with one double pole, double throw relay if you had it. So let's draw out our two sets of relay contacts. And again, just as a reminder, double pole means that there's two commons. So this terminal here would be one common, and this terminal would be another common. And then that common has two different sets that it can connect to. So this common can either connect to this one that we would call our normally closed contact, or it can connect to our normally open. And then same with this one, would be normally closed and normally open. And we represent that these are connected by putting a dashed line. So if one of these switches, the other switches. This kind of gives us the idea that this is one relay here. Yeah, so if we wanted to reverse it with just one relay, we can do that by bringing our positive and negative from the motor to the commons of one of those. And then we're just going to connect up our, let's add a positive source out here. So let's say this is a DC 24 volt source, negative like that. And then if we wanted to reverse this, or be able to control this, let's represent our control relay coil up here. So this is the coil that is controlling these two sets of contacts. So I'm just showing that as when we energize current through this coil, it's going to switch the state of these contacts. So let's say I brought negative to this terminal here, this normally closed terminal, and I brought positive to this normally closed terminal. So in this case, when the relay is not energized, so when there's no current going through the coil, you can see that there's going to be a path for electrons to flow through the motor in this direction. What if I then bring also the positive down to this normally open and bring the negative up to this normally open? So you can see when we don't energize the coil, current could flow like this. and that would give us clockwise motion. But then let's say we do energize the coil. So now current's flowing through the coil, and this would be done, through your PLC or push buttons or whatnot. Then these two contacts are going to change what their connection is, right? They're no longer going to be connected to the normally open terminal. Now they'll no longer be to the normally closed. Now they're connected to the normally open. And so now if we follow current through it, you'll see that now the current is still coming from the same source. So we still have current coming through here, comes down here. It is no longer going through this normally closed. Now it's coming down here and going this direction. You can see that, and back up, and now out and down to there. So that's a way we can reverse the DC motor with just one double pull, double throw relay. And then if we wanted to not only reverse the motor but turn it off and on, hopefully you can see that with this single relay configuration, the motor would always either be running in forwards or reverse direction. So if we want to give it an on-off control as well, we could add one more relay. So let's say our DC supply is over here now. We can add another relay here that is okay, so now hopefully you can see that this relay is now controlling whether there's power to the circuit or not. So if we kind of think through, if we call this CR1 and this is CR2, if we come up with a little truth table down here for CR1, CR2, and then the motor, so let's say CR1, let's start with, they're both off. So if they're both off, there's going to be no motor rotation at all because there's no power able to get to the motor. So we'll say motor off. So then let's turn CR1 on and leave CR2 off and see what that does. So now we've brought power. When we turn CR1 on, it's going to move these down. So now we have power. This one's still off, so it'll be in the normally closed configuration. So we would have clockwise rotation. Okay, let's leave CR1 on and then turn CR2 on. And what does that do? So now these will be down here. We'll have power flowing from here. But now we've switched to the normally open configuration on this one and this one, back to how we are here. So we would have counterclockwise. Okay, and then if we, for some reason, did the ones, if we have two choices here, there's going to be 4 different total states, right? We've done off, on. The one we haven't done yet is off, on. And you can see there that the motor will be off again, because if CR1's not on, there's no power to the circuit. So that's one way that you could reverse the motor and turn it on and off. And you could call this basically a motor on, and this is a direction. So one output from your PLC would set the direction, and one output from your PLC would set whether the motor's on or off. And that's totally one viable way to do it. But let's go ahead and do another way as well. Okay. So let's take a look at another option of how we could do it. We'll start with our DC motor again. And again, I'll say positive on top, negative on bottom is going to result in clockwise motion. Okay, so now instead of using one relay to do motor on-off and one motor to do relay direction, let's look at a way we can do 2 relays. One does clockwise motor on and one does counterclockwise motor off. So instead of one doing the direction and one doing on-off, we have 2 independent outputs from our PLC. One of them, when we turn it on, the motor will start running clockwise. We turn it off, the motor's off. And the other one, when we turn it on, it'll run the motor counterclockwise. So let's look at how we could do that. So I'm going to start out with another set of contacts. But what I'm going to do differently this time is that these contacts are not part of the same relay. So this would be, I'll put one coil below and one coil above. So we'll call this CR1, this one CR2, and connect those to there, like that. And again, bring positive off of one, negative off the other. And again, we'll have our positive source out here and a negative source. And this time we're going to do something like this. So the positive is going to connect to the two normally opens, and then the negative will connect to the two normally closed. So I'm betting you can see here now, if neither control relay coil is energized, so both of their sets of contacts are in their normally closed configuration, there'll be no rotation of the motor because both the negative and positive sides are both tied to the negative power supply. You see that there's basically just one loop here. There's no path for current to get from the positive to the negative. So again, let's draw our kind of truth table that we had before. So we'll say CR1, CR2, and the motor. Okay, so let's turn on CR1. So say CR1 on, CR2 off. So this contact will change states like this. And now you can see we have a path for current to flow. Current can come from the positive supply through the motor, out through the still closed set of contacts of CR2 into the negative power supply. So in this case, the polarity matches what our motor was, so that would be clockwise rotation. Okay, let's see what happens if I turn them both on. So CR1's contacts are going to stay how they are, but now this one will swap. So now you can see when they're both on, it's kind of just the opposite of when they were both off. Again, there's a loop, but it's tied to positive now. So again, there's no path for current to flow from the positive supply through the motor to ground. So the motor would be off if they're both on. Okay, let's look at if we leave CR1 off and CR2 on. So this would go back down to the normally closed. I guess I didn't label those, did I? Okay, so now we have CR1 off, so it's connected to the normally closed. CR2 is on, so it's connected to normally open. And now you can see current can flow from the positive through the normally open set, which is now closed, of CR2, through the motor and back to ground. So now the polarity is switched, right? We have positive is connecting to our negative terminal of the motor. So now we would have counterclockwise motion. Okay, and the last combination would be both off. And that's really what we had when we started, right? That would put this one back down here, and we have no rotation. So again, we're still using two relays, but now instead of having one relay that does motor on-off and one relay that does direction, we're using one relay to turn motor on clockwise and one relay to turn motor on counterclockwise. Just kind of different ways of doing the same thing, and it really would kind of depend on what you felt most comfortable with. So the last thing we're going to talk about is interlocking, and that's how we make sure that we don't accidentally energize the motor trying to go both directions at one time. So you can see it would be pretty hard to do that here because if we turn both relays on at the same time, we just tie them both to positive, or if they're both off, we tie them both to negative. But I do want just to remind you of what interlocking is and why we do it. And so we're going to wire our DC reversing circuit with interlocking, even though the way we wire it, even if we energized both relays at the same time, it wouldn't short out the wires, as can happen in some types of reversing. But I do want to just kind of walk through that process. So we're going to use this style of reversing, but I'm going to lay it out a little differently so that we can see how we're going to interlock. Before we draw the new schematic, let's just look at what we have here. We're using 2 relays, but you'll notice we're only using 1 contact set from each relay. And hopefully you remember that our relays have 2 sets of contacts in each actual box. So we're going to use the other set of contacts to interlock. So let's start on a new page. And to make it a little more clear, I'm going to draw out the 2 relays with both sets of contacts. So let's have, there's one set of contacts. So this would be common, common. This would be a normally open, normally closed, another normally open, and the normally closed. Those are connected and they're operated by the coil. So this is basically one relay, and then let's draw another one. Actually, sorry, I'm going to draw it smaller to make sure we have room for our wires. So let's do that again. Okay, there's one. And then let's just draw another one. Okay, so there's our 2 relays, and then we'll put our motor down here. And let's put our power supply up here. Okay, so we're going to use the second variety of reversing, where we used 1 relay for one direction and 1 relay for the other. So the key for that style is each common of 1 relay ties to one side of the motor, and then we're going to tie both our positives and negatives to, let's see if I have the electronic version of it here to make it more clear for you. No, I don't have it up, so we'll just keep drawing. Okay, so we'll tie, let's say we use the normally closed, I think is what we used for our negatives before. So bring that down and around. So both normally closed. We'll tie that to negative, and let's come down around here. And then the normally opens we'll tie to positive. is bring power. Okay, so that just duplicated pretty much everything we did on the previous page. If we grab that one back, you can see our two normally closed contacts are tied together and tied to negative. And so normally closed is tied to the other normally closed, and then to negative. Yep, that matches. And the positive went to both normally opens. So if we label this one CR1, CR2, you can see that if we close CR1, this will come down to here. And in that case, then that's the positive would flow through here. Current would go through the motor and out through the normally closed of this and back to the negative. So if we engage CR1, if this is positive and this is negative, then that would be clockwise, we would say. If we instead close CR2 and leave CR1 open, then this would close, and in that case the positive would be able to go through here, out and out through there, and back to negative, and then we would have counterclockwise. So we've duplicated this version that we did. What we're going to do now, though, is use the other set of contacts to interlock the coils so that we can only energize one coil at a time. So before, we just brought from our PLC maybe straight to positive and then went from the negative side of the coil to ground. What we're going to do now is run our signal. The signal that's going to run the coil of CR2, we're going to run it through the normally closed contact of CR1. So let's say this was coming from our PLC. We'll just call this PLC output 2, just for illustrative purposes. So it's going to go through the normally closed, and then it'll go up to the positive, and then it can come out here and tie to the negative, which the negative one is this right here. So hopefully you can see that if we want to turn on CR2, we'll energize the PLC output 2. That'll put a positive signal on here, and as long as CR1 isn't energized, the current will flow through and turn on CR2. If, however, we had already turned on CR1 so that this contact was down here in the normally open state, then it wouldn't be possible to turn on CR2 at the same time. So now we'll do the same thing for CR1. Just to make it a little neater, I'm going to switch the negative side of it. So let's say we use PLC 3 to switch CR1, so PLC 3. So we'll come straight from the PLC to the input of the coil, then we'll go out the coil through the normally closed of CR2, and then that will tie to ground. So here again you can see if I want to energize CR1, I turn on PLC output 3, but if CR2 is already energized, this would be down here then, and there would be no path to ground. So those are now interlocked. I can't energize coil of CR1 and CR2 at the same time. So we're going to do a variety of this schematic for your actual wiring. And again, when we're reversing using this fashion down here, we actually don't technically need to interlock the coils, but it's a good practice. And we have the extra set of contacts in the relay, so I want you to go through that exercise. Okay, so here is the electronic version of the schematic that I want you to wire. You've already connected up your lamps and push buttons and toggles as on the left side of the schematic here. But now we're going to add in these two relays. You can see CR1 and CR2. You can see they show the protective diode module on them that we've talked about before. You can see in the bottom half of each relay is the set of contacts that are doing the reversing. And then the top half set of contacts is doing the interlocking for each coil, just like we went through on the paper just now. So we're going to use outputs 4 and 5 from their PLC to control the two relays. So I will post a electronic copy of this on the assignment. So the first part of your assignment today is to wire up the schematic shown here with your PLC. So you can see you're going to have two wires that go from the relays back to the PLC, You're going to have 2 wires of power at least that come over here. You can land multiple wires under terminals on the relays if that's useful to you, to avoid running multiple wires back to the terminal blocks. So for example, here on terminal 14, you might bring a wire from terminal block 16 to terminal 14 on CR1, and then you might have another wire under the terminal 14 that goes to terminal 14 on CR2. And same thing on the 212s on 42 and A2. You can see there where you take advantage of that, able to put multiple wires under one terminal. Okay, so that's a pretty simple wiring task. I'll pause this and go put the camera on my trainer so you can see what it should look like when you're done. Okay, so you can see here I have my relays all wired up and my DC motor connected. I have a couple extra terminal blocks in here that you don't have yet since we had the weather closure. So for your red and black ones, your power supply, I showed you running them back down to the terminal block over by your push buttons. So yeah, just don't worry about the fact that you don't have those. You'll be getting those soon. So just use the blocks down over here for your positive and negative supplies. Also, don't worry about you don't have your stepper motor mounted, and I've got an extra PLC down here. I'm not sure if you can see that in the window or whatnot. But this is what you're focusing on now. And the couple things I wanted to talk about, just a reminder, I have written in pencil lightly CR1 and CR2 on the little label spot here, so that I can tell which one is which as I'm wiring. You'll also notice that each terminal on the relays has 2 different labels on it. So I'm going to pop a relay off here to make that a little more obvious to see. And so you can see this terminal right here, the top left one, is labeled both A2 and 14. This one's A1 and 13. And you can see I pulled the diode module off as well because I wanted you to see this little label here. It's showing that the top labels, A1, A2, 14, 13, etc., are labeled for the IEC format, and the bottom labels are labeled for the NEMA format. And you'll notice on the schematic I was using IEC. Like the coils are labeled A1 and A2. So looking at my schematic over there, you'll see labels A1, A2, and then the contacts are labeled 41, 42, and 44. So you can see that for the one set of contacts that has a common of 41, that's the common of 41 there, and then 42 is the normally closed set of contacts from this common, and then 44 down here is the normally open. And so if you're looking at the schematics, you'll notice that my schematic shows orange wire coming into 41. I happen to use green here. I guess I'm looking at the wrong one, sorry. That's 41. So this is the 41 we're talking about. And one thing I wanted to point out as a distinction for you is there are, I think it's 12s, yeah. See that for IEC, we use 12 on one side here as the normally closed contact. There's a NEMA 12 down here. So that'll make more sense as you're wiring yours probably, that you need to be real careful to make sure you're using the right number 12, so that you're always either using the numbers that are on the top or the numbers that are on the bottom. So we're using all IEC numbers. So A2, A1, 41, 11, 42, 12, 14, 44, that kind of thing. Hopefully that makes sense. So if not, you can always pop this off and refresh for yourself. Again, if you want to remind yourself what those numbers are actually connected to, you can always look on the side of the coil, of the relay coil here. Okay, so once you have it all wired, and again, you want to double check all your connections, and again I recommend you print out your schematic and check off each wire as you make a connection. Once you have it all connected, I've got power on mine here. The first step to check it before we actually do a program in the PLC is these little buttons here on the top are a way to mechanically move the armature of the solenoid and engage the relay. So this is kind of like a mechanical bypass. So if I push this, you can see that if I push down on CR1, my DC motor is rotating clockwise. If I push down on CR2, it's rotating counterclockwise. So that's a way to test to make sure everything was wired correctly. And you can actually lever up this little lever, and that bypasses it continually. Okay, so the first step is to wire it and then test it by mechanically overriding the relay. And next I'll give you the assignment for writing a PLC program to test those. Okay, so I'm going to get the PLC assignment. The instructions for that will be in the written assignment on my MHCC. So that's it for the video. I hope you got your relays working. Let me know if you're having any trouble with that. We'll be in class together on Wednesday briefly to pick up parts and whatnot. So if you're struggling, I'll try to remember to bring my trainer into class so you can take a look at how mine is wired and we can walk through any questions you have. So it's kind of a short assignment this week just because we're all kind of off schedule on parts and whatnot. So anticipate a longer assignment on Thursday after you've picked up parts, and I'm going to have you'll get some practice changing wiring. So I had you wire the push buttons in one configuration of syncing and sourcing for some push buttons, and later this week we will switch that because that's actually more common than wiring. New PLC wiring is coming in and rewiring something, and that's not quite as easy as wiring from scratch, because you have to remember, is this wire something that is the original configuration? Have I changed this? That kind of thing. So just a little heads up for what's coming later this week. So I hope this video has been clear enough. Let me know if you have any questions. See ya.